This is one of my personal favorite slides because it's very lazy. I tried to put a few words into it, but I want to get a point across. And this is, Ron was here last year, talked a lot about how we had different releases coming out over time. And I think that's really interesting, but I think it's also interesting to look at that as sort of how did we build our product up over time to become what it is today. And it's just a way to emphasize that we started with performance. We started with that concept of performance. And it wasn't just like, hey, I think we'll start with performance. It was customers that Ron and his team had been working with in these other companies who had these problems with performance, and so they knew they had to build that solution. We went to things like global namespace, which then provides sort of a ubiquitous, abstracted back-end environment access. We move into things like data management, the ability to mirror across sites, the ability to move data as I need to. And then with the object stores in the public clouds coming, we embrace sort of this hybrid cloud NAS. But then further, there's the new stuff. And so Ron alluded to it a little bit last year. So we've had for the last, I don't know, 8, 9, 10, 11, 12 months, we've had the ability to map Amazon in as a core filer. A core filer to us would just be one junction and, the client could write to it. And the client would think it's an NFS or a SMB connection. But what's been happening now is in the last year and a half maybe, lots of companies are now starting to say, okay, it's time. We need to start thinking about how we're going to move into the cloud. And even though we're talking about things in the concepts of storage, the real mojo, the real action, if you will, is in what these people are doing with compute. And the symbiotic relationship between what these people are doing with compute and how they deal with their data is a great inflection point in the industry. And it's a place that we're excited to be playing in. I'm afraid I'm going to go to this next slide, and luckily I don't think it's Gartner. oh no, it's some sort of marketing slide. Don't worry about it. But the point, I don't even care about the numbers so much. This was absconded from a different slide deck that I had. The point that was being made in this slide is simple, and that is people are now, we've moved past the hype phase of embracing cloud. Is everybody going into Amazon? No, not everybody's going into Amazon. Is everybody going into Google? No. Is everybody going to do their own open stack, Nova compute with some, Cinder connection block storage and etc.? No, they're not doing that. But what they all are doing is they're saying, okay, time for a change. It's time for us to think forward about how we're going to introduce DevOps into our IT environment and how we're going to automate much more of what we do in our environments and how we're going to take advantage of extending our compute infrastructure without having to buy or lease more real estate or take care of the cooling and the heating and the power and the human costs of maintaining our own data center, et cetera. They're not all saying, and we're going to throw everything away. They're just saying, how do we start moving into this place? And the way we had been approaching this last year is, we provide you ability to archive your data to S3, and that's a good thing. And you could set up a data archive in Amazon at a very, very low price because Amazon storage is very cheap. I'll stop there to see if anybody disagrees. No, it's cheap as dirt, right? I wonder why it's so cheap. Why would they be giving away the storage? Aren't they going to make any money off of those disks? Well, and you got hats off to them. It's the compute, right? It's the other services. Once the data's where it is, the services are great. They can make money off of them. People, IT organizations, enterprises can take advantage of that flexibility. So it's not about the petabytes. It's about the petaflops. There it is. We were looking for a Twitter thing, so we found it, right? So it really is a lot about the compute. And it's not that we're like, oh, we're leaving storage behind. It's, okay, I'm some company and I'm going to do genomic sequencing. And I've been doing it here and I've been running my scripts and I've been running, for example, Galaxy and Blast and all these things to do things, and it's all fine. But you know what? I'm out of space. I'm a university, and I have other university satellites that are interested in taking advantage of this infrastructure. If I put it in the cloud, that's a good thing for these people. But you know what? I don't want to put all the data in the cloud. Or I want to put some of the data in the cloud, or maybe it's scratch space. In other words, I want flexibility to set up a solution. a solution architecture. It's not about buying boxes. It's not about buying disks anymore. It's about putting together these solutions with compute, networking, and storage and other services. And yeah, I'm gonna lightly skip over some of the other services like, you know, online databases and such, because it doesn't fit my story as well, okay? But it's all part of the same equation. And so people are moving to the cloud, and they're moving to the cloud to take advantage of that compute. And so ultimately, we have a great opportunity, and we're starting with Amazon, and we're introducing one piece of product that's very important. And I didn't put a lot of slides in here because I didn't want to overslide you, and I'm going to explain instead. So I'm that next-gen sequencing company or enterprise, and I decide I'm going to spin up compute in Amazon. So I'm going to run 1,000 cores in Amazon, and I'm going to stick some next-generation genomic sequencing Galaxy platform up there running on Cloudman, and I'm going to make that available for people. Now, in next-gen, you know, in genomic sequencing, I need reference genes somewhere. So where shall I put them? Well, I can put them in S3. But my applications don't have native S3, right? Or I have reference genes, but maybe they're our own cadre of proprietary gene information, and I don't want to share them out in S3, so I'm going to keep them on the prem, right? So I'm going to keep the data down in my NetApp environment that's on-prem in my data center. I'm going to spin up some compute in Amazon. I got to get the data from down there up to there, or I've got to get the data from S3 to there, not permanently, for the purpose of the application, right? And so it's all about locating, caching, performance, and gateway access as close to the compute as you can, which is in the compute, right? And so it's a very logical place for us to go. We're introducing what we're calling the virtual FXT. I still want to joke about it, but Rebecca will kill me. But we tried VFXT, but we found that absolutely nobody in the universe could pronounce it. I'm not sure why.
It's like say it 5 times fast.
and VUFX just didn't cut it either. So it's the virtual FXT, okay? What we did is, for those of you that know us in this space, we have, you know, boxes, and we have OS hardened on it, and we put our intellectual property on that box, and we add memory and NVRAM to take advantage of things. What we've done is we've taken the intellectual property that we put on our box, and we ported it along with our free BSD kernel and our optimizations into Amazon virtual machines. And we're basically running our product as an Amazon virtual machine. Is it 100%? Let's just get that out of the way right now. Is it 100% like for like? No, of course it's not. It's not, you know, it's not a physical box. It's a virtual environment running in a hypervisor with some of the limitations that you would experience there. But it is software, and I can run lots of them. And I can run them and I can tear them down. And I can run them all the time, or I don't have to run them at all, right? And I can plug them in and give them access to the on-prem data or the S3 data, and from that compute that I just spun up in Amazon, it's an NFS mount. Yes?
I have a couple of questions.
Yes.
One is about EC2 is not very predictable about performance. So even if you get the best instance that you can have, all the networking stuff, you can get very different latencies and that kind of stuff.
Okay, so that's, yeah.
So from the scale-out perspective is not very predictable, like having physical stuff, okay?
Yeah, I guess
Yes.
the tolerance for variance is much lower on bare metal hardware once you go into the virtual environment.
It's a fantastic point that you're making. And so the best way to look at this, I'm kind of getting ahead of the game a little bit, but when you move into the virtual world, the laws of physics change, if you will, from what you did in, you know, I bought this box and it has everything self-controlled and so on. I'm now in this virtual world. There's different rules. Amazon has their SLAs. You're in certain data centers. It's volatile and so on and so forth. Depends on how you look at that. I don't think we view that as a problem. We view that as an opportunity that we're going to evolve into, because guess what? Just like Amazon has that environment with its foibles and its characteristics, so will all the other players that we end up evolving into. And so the value that we intend to add as a company is to help to adapt and work in that environment to provide similar services as to what we're providing in the physical environment. Because one thing is for certain, and that is over the coming years, the amount of data isn't going to shrink. The amount of bandwidth is going to grow, but not to the pace of the amount of demand. And so if every company suddenly decided tomorrow to rewrite all of their applications so that they could take advantage of S3 object or another object standard, they would still run into some problems there. And so there's going to be this need for a long, long time to provide optimal access. And what I'm saying is, it's just that what we defined as optimal access in the physical world is probably going to slightly change, or maybe even in some cases radically change. You may need more nodes, for example, running simultaneously in the cluster. We may need to think down the line about sort of splitting the work and think about different models about that. One of the things that we were pretty conscious of doing is trying to minimize the amount of what I'll call Amazon-specific attributes. If you're familiar with AWS, there's different pieces, parts, and we're going to sketch some of it out in a whiteboard that you can take advantage of that would maybe give you the ability to locate all of your compute close by to get better network performance and such. We kind of stayed away from as much of that as we can. That means that our first product out doesn't have, the most perfect latency, the most perfect performance, but that's okay because we're on the other nice thing about not having to worry about releasing a new hardware platform with this is we can continuously iterate the performance and iterate an update to that particular software. Question?
Yeah, so the solution can then mirror data to CleverSafe or Amplidata or any of these other cloud solutions running in EC2? Is that?
Well, ultimately, if you were to look at I don't know if I have I have a picture. Okay, I cannot take credit for the animation in this picture either, but this gives you kind of a feel for it. So I'm going to actually go quickly through it because there are cartoon turtles located in it as well. The idea here is that disk storage is ultimately slow. S3 is not exactly familiar with all these applications. I mean, there's going to be a long-going debate about which vendors of which applications are going to convert to having native S3 or another native standard. And by the way, how many thousands of homegrown IT applications aren't, right? Because they're just not going to do it. They'll rewrite it or they'll come up with something else. And so ultimately, there are performance bottlenecks in the storage cloud. There's bottlenecks on-prem. And so to your point, this down here on-prem could be a combination of NetApp Filer, could be a CleverSafe object store, it could be Amplidata object store, or whatever. And then there could be compute in both places. And so how do you grow this and how do you, I'm sorry, is somebody taking a picture? Do I need to back up? No?
You're good.
All right, so I'm skipping right to this. And so this is sort of how we see the ultimate flexibility. So again, thinking in terms of it's all about where the compute is and how to get the data close to it, which is what it's all about. We provide really the optimal solution in many ways because you could have a combination of physical FXTs running on-prem, providing access to compute that's on-prem to data that's up in the cloud, or maybe it's data that's in a remote Amplidata object store site, for example.
So can a global namespace span the physical and virtual FXTs across these compute clouds and on-prem compute?
Mm-hmm. Absolutely.
Nodding yes, folks.
I'm drinking coffee. Yes, it can.
Yes.
Yes, it can.
Yeah. So I mean, just to give you a little more, the global namespace is really configured, scoped for each cluster. But
so a cluster
can
can
just
span on-prem and off-prem?
No. These are separate clusters. But you can configure a global.
Clusters?
Oh yeah, absolutely.
Wait.
But mapped together. Go ahead.
Are they separate clusters? Or
Yeah.
are they
Yes. Yeah.
Right.
Well, then effectively you're just mirroring the data.
No.
Mapping.
We're not. Remember, we're not storing the data.
I understand,
Right.
but you're mirroring the compute cloud data to both the on-prem and off-prem solution and the physical on-prem compute data to both off-prem and on-prem. But the global namespace does not span both the physical and virtual FXT solutions on this page.
Yeah, your point is there's not one mount point.
Yeah. Well, so
Yes.
there's the layer of core filers, and then there's the layer of edge filers above it. Let's just say, and let's say there's a line down the middle. There are two separate edge filer clusters.
Yeah. I got you.
They can crisscross and construct a namespace that's identical to clients mounting either one of them.
Yeah, there's ways that
And I have a demo that I'll show you guys.
that we'll show you. We won't even whiteboard it. We won't even try. He'll just literally show you in a virtual FXT how we would do that.
So can connect to the same NAS boxes, depending on whether you're virtual or physical. That's not a problem.
Yeah.
The same directories.
Yep.
Yeah.
something's not clear yet. So you're gonna have to show this to me.
Yeah, we'll show it to you, and if it's still not clear, we'll hack our way through
To
it.
clarify, your use case is basically that you want to use your own on-prem storage for your EC2 compute.
Yeah.
So that's why you've got virtual FXT.
We have a lot of people that are doing that. We also have people that are looking at doing 100% in the cloud. So they may not be the largest enterprise. They may be like a small rendering shop. This gives them the economic advantage.
Okay, so at the same time, do you have a product that is virtual FXT for on-prem, like for VMware or
Not yet.
Hyper-V or anything like that?
Not yet. Roadmap, absolutely. In fact, there was a big debate. I'll just, I don't mind dirty laundry. I mean, we were debating when, because I have a slide. Did I do it? No, I probably didn't do it. I had this slide that I didn't put in here. And it was sort of the vision slide, because I didn't want to over-vision you. But the idea was, in the end, when you start thinking about like ubiquitous object store, wherever it's at, and you want to apply that to an enterprise, right? Well, access becomes the problem then, right? So what do I do about my Soho offices? What do I do about my small and medium businesses that are partners that I want to have transact? And how do I, and I know this is one of the main things, how do I make sure ultimately that I'm able to write to a file without conflict, ultimately? And so we have a path to get there. Ron hinted, I think, towards it last year, talking about some notion of a global file system. Think of global file system as sort of a universal write token management capability across clusters so that you could always not have that collision. And so, back to your point, these remote sites, they may have an ESXi hypervisor system. Why wouldn't we want to be able to ultimately run our IP on that as well?
Right. Is there a price difference based off of virtual FXT and your physical FXT?
They're both $3 million each. No, I'm just kidding. That one's for corporate, so it was good knowing you all. But no, I mean, yeah, there's a price difference, and the economics are different as well. Ultimately, you'll be running that on an Amazon infrastructure, and we take that into account as we price the virtual piece.
Is it also available on the marketplace so you can buy it as a...
Great question. So in the first release, we're a fairly conservative company in that approach because we want to make sure that the people that are adopting it early have really good success. So we want to make sure that we can support them. By unleashing it into the marketplace, we're taking on all use cases simultaneously. And so we want to be very cautious about that until we get to a certain level of confidence in terms of overall. But we already have this thing running in a major, what would you call them, enterprise, I guess it would be. Several of our rendering customers are running workloads in EC2 against their on-prem data, NFS. We're talking right now, we're closing up some beta programs with some life sciences people that want to do computational, but the data has to stay on-prem. So it's more of a conservative approach. It's not like we shouldn't do that. It's just we want to
basically the bring your own license model right now.
Yeah. Plus, a lot of the customers that we deal with aren't sort of one shop, one floor. They're working with a giant application or set of applications with a certain throughput expectation. Yes?
I'm sorry. Just laughing to myself. Go ahead. That Twitter stream.
Now, when you store your files, are you actually storing it in the original format, or are you trying to do some sort of reduction when it goes to S3 to save the customers money and space?
Yeah, we
chunk up the files into object payloads, and then we compress that data, and so that gets the way we put those objects to the object-based storage.
Is there any sort of deduplication on upload or pre-upload, any of that?
So we've done the analysis for dedupe. We're still not there yet with when we're going to do that because conceptually speaking, it really depends on the customer. So a lot of people that are in private store, they have asked about dedupe, but then when you talk it through with them, I mean, I'm not sure that they're realizing.
Well, specifically for something where you are going over a WAN, going up to S3, when you look at Riverbed Whitewater or the Steel Store product,
yeah,
I mean,
I think
you're shrinking your transfer, you're shrinking what you're stored. I mean, if you
so I think it really depends on the data sets that you're working with as well, right? If they're the customer application will generate data that may not be dedupable or may, right? Backup applications usually generate dedupable streams, right? So that's where the products like Riverbed and whatnot are focusing effort because there's a lot of value to be had there. Our customers are not necessarily working with data sets like that because we're working more in the compute space with actual real data files that aren't necessarily dedupable across the entire set of files. Now, some of them are working like the genomic stuff. That stuff compresses really well because it's basically text files of 4 characters each, TCAG or whatever. So that, as you write that out to an object store, gets compressed really well.
Yeah. But
So there's a whole spectrum of kind of efficiency that you can see there.
it's in our roadmap futures because it does come up on a fairly frequent basis, especially when we're talking enterprises for that reason that you're mentioning, is that they're thinking about their cost basis. But they're also largely thinking about it archivally at that point. They're thinking about archives. So
One of the things you mentioned before was it was around the discussion around subdirectories, but you want to be able to, if somebody took your system out, you don't want to have files chunked all over the place. If you were to do dedupe and you take your system out,
They're already chunking it into non-usable files.
okay.
So if you already are, if you're making it inaccessible, why not?
In order to get the POSIX file system semantics on an object-based storage, there's a lot of challenges there.
Right.
And, chunking the data up is, certainly also a way to help kind of wrangle that all in so that you can actually, because our Flash Cloud is a fully POSIX compliant file system, hard links, everything. So the whole idea there is that you get that uniform experience for your applications. Some other gateways that maintain the object integrity on the back end can't offer those type of semantics, and some applications can't deal with that.
yeah. So
You guys talked about QoS a little bit just now. Are there any features that actually reserve the number of NFS ops to a certain application sets and so on and so forth?
not today.
No. I mean, I'd say if anything, it's more of like a class of service, right? And we catalog or we determine the class based on the access patterns for a file, and that's like the fundamental tiering performance technology that's in our product. In terms of, do I put it in SSD? Do I put it in RAM? Do I put it on my SAS drives? Do I leave it on the core filer? And that's like the class of service in terms of ranking. The stuff that is most popular, most accessed is going to get the highest level of performance.
So
But there's no guarantee. Yeah, there's no
that determines what's going to be.
Exactly, and there's no real hard quality of service. I mean, he and I worked in the ATM networking world 15 years ago, and that was as close as quality of service as you could get because they would chunk everything into fixed payloads and meter every single cell that was going across the wire, and it was a lot of overhead.
It was.
But it worked.
Yeah.
But no one knew how to use it in the end.
Right. where we think that's going to start playing a role is if we start getting a lot of traction with full-blown service provider multi-tenancy. Then it's going to become a matter of, because then it's an economic, I want to pay for better service type of thing. But a lot of the genomics folks that we've been talking about haven't said they want preference for one university versus another or anything like that yet. That doesn't mean it's not. It's the same thing with dedupe. I mean, there's a raft of features out there. Now it's a question of ordering that list in a way that we pick the right ones that are as close to that.
Now, with the actual VM for EC2, is that clusterable with other VMs for EC2 that you have? Like, can you spread your namespace up in EC2 among multiple instances, or is it just one?
You run a minimum of 3.
The EC2 instances are like the building block for the the VFXT cluster, the virtual
Now,
FXT
the
cluster.
storage they're primarily sitting on is it EBS, which
EBS.
Yeah, it's EBS
so
general purpose.
With EBS being able to have IOPS SLAs in place, is there any possibility or future roadmap to say, all right, this one EC2 instance has this many IOPS, this one is this many, where you're actually favoring cluster nodes for certain directories, or saying this one subdirectory is locked to this one VM because that's my fastest IOPS SLA on.
I think that's bleeding to the whole vision of and combining that with sort of that laws of physics. When we get to the cloud, things like that are suddenly very plausible because you can ramp up a new feature like that and widely deploy it to your customer base without having
that's really no
overhead.
different than what you'd be able to do on-prem.
Except you don't have to ship boxes and refresh everybody's hardware and if there's any problem. Like, I'll give you a great example. I mean, if you think about the life cycle of these things. So right now today, and we'll put this out there, the first, we're not blanket supporting every possible Amazon EC2 instance type because that would make no sense. Like running our stuff on a micro, probably wouldn't give you really good performance, I guess is what I'm trying to say. So what we did is there's one machine that we're going to support out of the gate right away, which is the R3.2XL memory optimized instance type. Why do we only support one? We wanted our QA team laser focused to beat it up and to see what we could find and learn. We will quickly move to the R3.8 extra large, which is the largest of the memory optimized bunch, 244 gig of RAM. There's some work we need to do in the background on that just to make sure that we're able to fully optimize the virtual CPUs that are running on R3.8 XL. But I say that, and then I say what we're signing up for really is lifecycle management that's sort of different than the hardware world. We don't know at what rapidity Amazon or others are going to refresh their instance model types, and so there'll be a constant ability to update that. But the nice thing about it is you can change instance types as well. So we're really at that point right now where we're learning all of the different parameters of this new world and how flexible and how fast we can move to upgrade things and change things. So we don't have all the answers today. I hope nobody thinks they have all the answers. I'd like to meet them and sit with them for a while. But
I have a question about how do you manage data on S3 instead of the NAS. So in the NAS, you don't touch the backend file. Now the file is still the same.
Yeah.
Okay, and the structure is the same. Can do a lot of stuff. But more or less, I have my files.
yeah.
On the object storage side, you said you
Chunk, yep.
you chunk down. So I do not have the files anymore.
If you wanted to take a native S3 client and point it at that bucket and try and read that data, no, it's not going to fly.
However, so two things to that. So one, we don't publish it today, but a utility to allow you to back your data out into a file format. Because remember, when we're chunking, we're not just like blindly chunking. We're adding metadata, object information, so that you can put it back.
The chunking also for spreading data.
Yeah, and for partial updates to files and stuff like that. Yeah.
But you lose the control of the files. So even if you have 1 million files, you lose control of your data.
As it's built today,
Not you as a viewer, you as a
As a customer?
well,
Well, I mean, so you're saying that they're locked in?
Yeah.
Well, that's what the flash move and flash mirror functionality comes in, right? Because then they can take now what our flash cloud file system is sitting backed by an S3 bucket, and they're like, I want to move this back on-prem to my Ampli data, let's say, right? They can now take a flash mirror or flash move job and say, I want you to read all the data out of there and write it out to the Ampli data and flip the switch without the clients even realizing that the file
or order your legacy NAS environment if you didn't like your
or you could,
experience on
or if you're like, this isn't working for object, I want to move it back to NAS, you can do that. So that's the whole, that was the third.
Data, so in the Ampli data, you can't unchunk the files.
No, it'll be rechunked as it's put there, but it's not locked in. You can move it off the Ampli data back onto NAS.
Yeah.
That's the whole. So that was like the pyramid that Scott built there with the data management layer coming before the cloud layer was really to make sure that we had those bases covered so that we didn't have the lock-in problem.
Our ultimate goal is there's two ways you can go about it. One strategy is let's build something that'll trap people and then build an economic model that squeezes it out of them until they can't take it anymore. We're really not looking to get there because it's too in flux. Did you have a?
Now, if a customer did have an on-premise solution, and let's say they had a fire, wiped it out, but they still had their stuff in S3, would you enable like an instant turn on and read-only support to get data out of S3 for recovery? That's something a couple other
So you're saying they had their on-prem NAS and they were mirroring that data into S3 using our flash cloud and flash mirror? Yeah, absolutely, yeah.
Now that would be
Just remount the clients.
with the VM support. So your VMs.
Oh yeah, you could spin up an Amazon EC2 VFX or virtual FXT instance, point it at that bucket, and spin up your compute even in EC2. If your complete data center just burned down and you're like, I need to get my stuff back up and running and compute, you could conceivably
You could
do that.
definitely do that, yeah.
And you can actually mirror to multiple locations or
No,
Today it's one.
just one destination.
okay.
Not sure what the roadmap says in terms of that. We really want to see what our customers come back with us because there's so many different ways that they're thinking about this at this point.